Welcome back, ladies and gentlemen. As promised, this will be a lesson about Unity colliders and triggers, but this will not be only a knowledge tied to this particular game, but more like a general game development knowledge. Also for Unity and for other engines, because every game should use colliders like this. For demonstration purposes, I will be creating some new game object that we will not be using in the game, but just to show you how it really works. Go ahead and create two new sprites. The first sprite will be named fixed because it won't be moving, and the second one can be named moving. They still don't have any images, so let's go ahead and attach some image. This should work fine. And for this, we would choose a different kind of image. For example, this one. We want this image to be moving, so we will go ahead and add a component, physics 2D, rigid body 2D, and that will enable 2D physics on this game object. When we press play, it should start falling down. We notice that it fell right through this game object. That's because none of these game objects have colliders. Let's go ahead and add a box collider to this one, and a circle collider to this one. If we press play now, the objects should bump into each other. Now that we see that they are interacting, I want to show you also how 2D and 3D objects do not interact with each other, but we can have both of them in the same project. So let's go ahead and create a new 3D object. We can just choose a simple cube. The cube already has a box collider on it by default. We want it to be moving, so let's go ahead and enable physics by adding a rigid body to it. But this time we won't be choosing the physics 2D, but instead we'll choose just physics. Add the rigid body without the 2D. We also want to set the Z position to 0 because that matters with 3D objects. When we look at it from this perspective, it seems like this is a simple 2D object, but if we go ahead and switch the view to 3D by clicking on this, we can see that it indeed is a 3D object. So if we press play now, both objects should be moving, but only this one will bump into the fixed object because 2D and 3D objects cannot interact with each other. However, if we had another 3D object that's going to be fixed, we can expand it a little bit and drag it here. It should interact with this game object. Also make sure to set the Z position to 0. And it doesn't need any more changing. Okay, now that you know how colliders interact with each other, let's go ahead and delete these 3D objects. If we take a closer look at the circle collider component, we can see various options. One of these options is the isTrigger option. What that means is that the objects will no longer bump into each other. For example, if this object has the isTrigger enabled, they will not bump into each other anymore, but instead this object will pass through this object, and Unity will note that this object passed through this position. So let's go ahead and see how it works. It seems like nothing happened, but Unity indeed registered the movement through this collider. What we usually do, we have one fixed object that has the isTrigger enabled on its collider, and we have a normal object without the isTrigger enabled pass through it, and then when it passes through, we have some kind of action occurring. Usually we have some kind of code executing at that point. To show you that, let's go ahead and create a new C# script, and we can name it Trigger Demonstration. Open it up in Visual Studio, and let's go ahead and delete these two methods for now. When we enable the isTrigger option, this collider is no longer a collider, but instead it is referred to as a trigger in Unity. We have three checkpoints in Unity when some object collides with a trigger. First we have the object entering the trigger, then we have the object staying within the trigger, and we have the object exiting the trigger. Those are all different checkpoints in Unity. To show you that, let's enter the coding. If we want to check when something entered the trigger, we use a pre-made method called onTriggerEnter, and in our case it's a 2D. So whenever something enters the trigger, we want to send a message. To do that, type debug.log, and then we can type whatever message we want. In this case, we'll type the object has entered the trigger. So let's see if it works. Save it, and then add this script to our fixed object. And we see that in our console we have the message, the object has entered the trigger. Let's take a look at the other trigger methods. So we have onTriggerEnter and we have onTriggerExit. 2D, of course. The code within these brackets will be called once something exits the trigger. So let's go ahead and copy this message. But we want to change this to has left the trigger. Save it, and let's go ahead and see if it works. Okay, so now we have two messages. Once when this object entered the trigger right here, then it stayed for a number of frames within the trigger, and when it got to this point, it left the trigger, and we have this message right here. So as you might have guessed by now, there's also a method called onTriggerStay 2D. The code between these brackets will be executed while some object is staying within this trigger. So we can copy this once again. Save it and see how it works now. So now we have a lot of messages. We have one message when the object was falling down and entered the trigger for the first time. Then it stayed within this trigger for about 10 frames. And when it finally left, we have this final message. I hope this lesson improved your understanding of how triggers work within Unity, and it's mostly the same in other game engines as well. Now that we are done with this demonstration, we can go ahead and delete these two objects since we won't be using them in the game.